I'm embarrassed to admit that I've never been in India before. I'm happy to be here now, however, for many reasons, but most prominent of which is that I've had a chance during the last several years to work with Professor Skaria in many different settings, Copyright X, Patent X, and a growing set of projects that try to put some of the ideas embodied in those courses and that I'll be discussing today into practice. So I'm grateful for all we've been able to do together already, and I'm hopeful that we can do much more in the future. I will be speaking for approximately 45 to 50 minutes. The plan is to spend the slightly less than half of the time discouraging you, explaining how troubling the situation in public health in the world at large, and particularly in developing countries, is today, and how the threats on the horizon are even more worrisome than the conditions under which we are currently living. And then, I hope, in the second portion of the lecture, slightly more than half of the time, to offer some solutions, many, but not all of which will involve adjustments in the legal system or strategic harnessing of the legal system. So that's the plan. It's a lecture that follows the traditional narrative arc of descent into hell and then back into the light, I hope. So we'll begin with problems. There are two major dimensions of what I will be describing as the global health crisis. The first is that the threats to human health posed by many diseases are currently increasing. The best known, of course, is the COVID-19 pandemic, which has, as of today, given rise to 760 million cases and over 7 million deaths. The pandemic is not over. Indeed, as you can see here, globally, we are still witnessing about 65,000 cases a week and about 1,000 deaths a week. Those would be very big numbers if we were confronting a new disease, like Mpox, for example. They only look small because we have come out of a period of much greater threat. Okay, so the COVID pandemic is the biggest and most visible of the recent threats to global public health. But it is not the first pandemic. There have been even more serious ones many times in the past, nor will it be the last. Immediately on the horizon is Ebola, which has been simmering in West Africa, West and Central Africa for decades, and occasionally explodes, as it did in the outbreak in Sierra Leone some years ago. Little known is the fact that, but for some luck, Ebola almost had a catastrophic impact on Lagos, Nigeria, one of the largest cities in the world. So more pandemics, specifically more pandemics involving outbreaks of infectious diseases, are coming, and we are not well prepared for them. If we turn then to chronic infectious diseases, the one that looms largest in the world today is tuberculosis. It looms largest in the sense that it kills more people than any other infectious disease. As this diagram indicates, the trend for a long time was improvement. It appeared we were gradually winning the war against tuberculosis. But in the last couple of years, that line of improvement has halted, and tuberculosis is now either rising or steady in the death rates. Most worrisome of all is the explosion of multi-drug resistant tuberculosis, which, as its name suggests, is not vulnerable to cure through any of the standard treatments. I'll come back later to what we can do, what we may have to do about this. Malaria, another major killer in the infectious disease category. Again, starting at about 2000, we had a general sense of optimism. The death rates were falling, but then in the last couple of years, progress has halted and indeed reversed. And that's true not just of the total number of deaths, but the age standardized death rate. As you can see, globally, it's going back up. AIDS. In approximately 2006, this was the biggest killer among the infectious diseases in the world, killed about 2 million people a year. For a while, things seemed to be getting better. And later in this talk, I'll explain the forces that enabled us to bring the death rate down. But this is much more worrisome. In the last 5 years, the death rate from AIDS has not materially dropped. Okay, leaving infectious disease to one side, turn now to non-communicable conditions. This is cancer. Currently kills about 10 million people a year. So notice the scale has changed. We're now in a much larger zone. The World Health Organization, OECD, predicts that by 2050, cancer will kill about 18 million people a year. So the rate's going up much faster than population growth. Parkinson's, another non-communicable condition, kills fewer people, but it too is rising at an extraordinary rate. So since 2016, both the prevalence and the death rates, age standardized, have risen by about 20%, and we don't know why. And if you don't know why, it's very hard to devise a strategy to stop it. These are global age standardized prevalence rates for diabetes, type 2 diabetes in particular. As you can see, it too has been steadily rising. It currently costs us collectively in the world about $1 trillion a year to deal with type 2 diabetes, and that, as you can see, is slated to begin. So I don't want to leave the impression that it's all doom and gloom. There's a significant amount of progress that's been made recently in addressing some major diseases. The biggest is cardiovascular disease, which is the largest killer numerically in the world today. And heart disease, as you can see, has been declining. And unlike the graphs I showed you for tuberculosis and malaria, there isn't any flip up at the end. We seem to be getting better and better. Same is true of lower respiratory infections. This primarily means pneumonia. For a long time, as you can tell from the orange zone on this chart, this was a huge killer of kids under the age of 5, meaning order of magnitude 2 million a year around 1990. And that has been shrinking dramatically, enough to offset the increase in the incidence within older people like me. Cancer. Within the complex set of cancers, we are making significant progress on a few fronts. So this is stomach cancer, and this is lung cancer. The trend lines here, trend lines are good. And last but not least, with respect to sources of conceivable optimism, is COVID vaccines. What this chart shows is the difference between the total number of deaths, that's the gray zone at the bottom, and the estimated set number of deaths globally that would have occurred in the absence of the vaccines. That's the red line at the top. And the blue zone between there, that's how many lives were saved. This is a technological miracle. No vaccine in history has been developed and deployed this fast, and it saved a lot of lives. Okay, so the general point is many of the major diseases, especially but not exclusively infectious diseases, are getting worse, and the threats they pose are increasing. There are a few fronts on which we seem to be winning the war, but not most of them. We turn then to the second of the two major sectors of the global health crisis. This is inequality. The disease burdens borne by low and middle income countries exceed substantially the burdens borne by upper income countries, and we are likely to see an increase, not a decrease, in that disparity. So for the next 2 or 3 minutes, I'm going to show you a bunch of maps, and these are all I put together using the most recent World Health Organization data. That means they're all derived from 2019, which is the last time the World Health Organization made these data available. That means they don't include the COVID pandemic, but it's a pretty good indication of where we stand. In every one of these maps, there's a color scheme. Red is bad, green is good, dark red is especially bad, dark green is especially good. And that, I hope, will enable you quickly to see the pattern. This is tuberculosis. As you can see, it's very heavily concentrated in southern Africa, Southeast Asia, and India. This is malaria, even more heavily concentrated in southern Africa. That's not because people in Latin America don't get malaria. They do. It's because the strain that is common in Africa is much more likely to give rise to deaths. This is HIV/AIDS. As you can see, the southernmost sector of sub-Saharan Africa is the most heavily affected. This is respiratory infections, which, as I indicated earlier, seems to be getting better, but it's still a very big killer. And as you can see, this is much more widely distributed across the global south. This is not so heavily concentrated in Africa and Southeast Asia. This is one of the, to me anyway, most surprising of the graphs the maps that emerged from this data. It is widely thought that diabetes is an affliction of wealthy countries where people eat too many hamburgers. And that turns out to be not true. Diabetes, in terms of age-standardized mortality, affects the global south more than the north. Cardiovascular diseases are more evenly distributed through the world, although North America and Western Europe largely escapes the heaviest of the footprints. Now, cancer is very complicated. If you want, during the Q&A period, I can show you the different footprints of the different kinds of cancers. So in the aggregate, this is the pattern of cancer, but breast cancer and prostate cancer are the most heavily impressed on the global south. Parkinson's disease, as I indicated earlier, we don't know what has caused the upsurge in Parkinson's disease, nor can we explain this geographic pattern in which almost everyone except portions of Latin America are very adversely affected. So we distill from all of these, we get an aggregate pattern, which is this. This is the life expectancy at birth in the world today, and this is an adjustment of that data to take into account periods of time spent in ill health, morbidity. So some contrasts here stand out, some of which are surprising. The country in the world where healthy life expectancy is the highest, the major country in the world, is Japan, 74. It's actually slightly higher in Hong Kong, but not considered currently a separate country. Most of Western Europe is in the 70s, as is Australia. The United States is not. The United States is 66. That's approximately the same as in China. Indeed, China is 68. India is 60, a significant drop. Sub-Saharan Africa is in deep trouble. So the contrast here is grim. From 74 in Japan to 44 in the Central African Republic. That is an enormous degree of global inequality. Okay, so those are the dimensions of the global health crisis. Drugs, specifically vaccines and medicines, could help a great deal in alleviating both dimensions of this crisis. To get a sense of how, we'll turn to the relevant history of the United States, which is in reasonably good shape now with respect to infectious diseases. But it wasn't in 1900. The prevalence of infectious diseases in 1900 in the United States was approximately the same as it is in Zimbabwe today. So how, over the course of 120 years, were infectious diseases beat back? The big blip here that you can see on the left-hand side of the chart, that's the so-called Spanish flu pandemic. But other than that, as you can see, steady improvement. What caused it? Well, three overlapping things. First is public health initiatives, like cleaning up the water, the food system, sanitation systems, and improvements in personal hygiene. That was the level number one. Overlapping were the development of vaccines, which almost all of which were invented and then widely distributed between 1940 and the 1980s. Most of the major infectious diseases were suppressed by vaccines. And the last is medicines, of which the most important are antibiotics. The historians who study the relative importance of these trends seem to indicate that the period of greatest decline, meaning the most rapid decline, which is good, was in the middle, and it's attributable to the vaccines. As you can see, 8.2% per year decline in the rate. Okay, so we could harness this general lesson, prevent diseases with vaccines, and treat those that do arise with medicines. Unfortunately, the potential of those strategies to address the global health crisis is limited by four factors. Number one, incentives to develop appropriate vaccines and medicines are inadequate. So here we start to encroach on intellectual property law, for those interested in this field. Incentives to produce vaccines that address the infectious diseases most common in rich countries are just fine, and helps to explain why vaccines that address them are now readily available. The so-called neglected diseases are neglected because they disproportionately affect poor countries, and for very few of them are there vaccines. The ones for which there are vaccines are outlined in red, and the dotted lines indicate there's a vaccine, but it's not very good. And as you can see, for the large majority, we don't have that vaccine at all. Why? Well, because for reasons we'll be exploring later in the lecture, there are inadequate incentives to produce them. Number two, all too often existing drugs, meaning drugs that have been developed and tested, are not available in low and middle income countries, or are available but only at prices that most people can't afford. So let's, by way of example, take up multiple drug-resistant tuberculosis. The country in the world with the highest rate is India. The cost of a course of treatment for MDR-TB is in India approximately $4,000, which places it outside the reach of the large majority of the residents of the country. Here's another example. Sickle cell anemia is a grim, brutal disease that is confined to Africans or African Americans. That leads, not surprisingly, to this footprint where sickle cell anemia is very heavily concentrated in Africa itself, or where Africans or people of African descent have settled. For a very long time, there wasn't much you could do about sickle cell anemia, but recently, as in the last year, there's been a breakthrough in this area using some gene therapies And there are 2 drugs now approved by the FDA as of a few months ago. What do they cost? They cost $2 to $3 million per person, placing them obviously outside the reach of virtually everyone who's afflicted by the condition. Okay, so the first of the problems is that the second of the problems is that the drugs that are available are often, the drugs that have been invented and tested are often either not available in developing countries or available only at unaffordable prices. So it's important, I think, to stop here and ask why, because when designing a solution, you have to have a sense of causes. Sometimes the reason is intellectual property rights. The most recently developed of the drugs are subject to patents and data exclusivity protections, which can, in the hands of profit-maximizing firms, give rise to monopolistic pricing and placing the drugs, therefore, out of the reach of people in many countries. Okay, that's a problem. But it turns out not to be as common a source of the problem as is typically thought among intellectual property scholars. At least as important are the following things. First, proprietary technologies and trade secrecy, which can be just as effective in limiting access as intellectual property rights. Here, for example, is a statement by the CEO of Moderna saying why he was completely unconcerned by the World Trade Organization's initiatives to override Moderna's patent rights. He says, I don't care, because my patents are unnecessary. The technology, the mRNA technology, is very complicated, and nobody will be able to do it within the time frame. So complexity and trade secrets will be enough. Excessive profits by distributors. Even when the manufacturers are willing to put the drugs onto the market, distributors frequently charge very large fees in the middle of the road. The slow pace of regulatory approval processes in many developing countries can result in delays of 1, 2, 3, 6, 7 years before drugs are even approved for distribution. And finally, export controls, particularly in times of shortage. This is a factor that's attributable to national governments, not to strategic decisions by companies. The US and the EU are notorious on this front, but India is not immune to this problem. And specifically in the spring of 2021, when the Indian government, responding to a surge in COVID here, shut down exports of COVID vaccines, the result was to leave many African countries high and dry, which has produced a fact in the world now we have to take account of, which is public health experts and government officials in Africa are furious, and they are now insistent in multiple global fora on developing local production systems, because never again do they want to be dependent upon production in the US and Europe or on India. Okay, so back to the litany of problems we have to solve. We're almost there. We've nearly reached the bottom of the valley. Number 3, many of the drugs currently distributed in both upper-income countries and lower-income countries are substandard or falsified. The numbers here are globally approximately 10%. It's an especially serious problem with respect to malaria and antibiotics. In Nigeria alone, 74,000 children under the age of 5 die every year from consuming counterfeit or substandard anti-malarial drugs. In the world at large, the number is approximately 122,000. Antibiotics are widely, counterfeit antibiotics are widely distributed in Latin America. In both Africa and Latin America, there's a substantial number of counterfeit contraceptives being distributed. Fourth and last, antimicrobial resistance is increasing rapidly in the world. So I indicated earlier that the second of the 2 major initiatives in the 20th century that enable us to suppress infectious diseases was antibiotics. We are now losing that war because Very few new antimicrobial drugs are being produced, and resistance to the existing ones are going up rapidly. So the numbers here globally, approximately 1.2 million people die every year now directly from antimicrobial resistance, meaning the drugs we want to use on them just don't work. And the World Health Organization and the OECD predicts that the number will be 10 million by 2050. That's in your lifetimes, not in mine, but it's in yours. Now you might say, well, okay, that's 25 years down the road. The growth here reflects the growth in the population of the world, and that turns out not to be true. So we'll briefly dip into the population of the world. In 1960 was 3 billion people. In 2000 was 6 billion people. Today is 8 billion people. In 2050 will be approximately 9.5 billion. Against that backdrop, if we plot on the right-hand side of this chart, deaths from antimicrobial resistance, now plotted in millions, not billions. This is the situation today, and this is the situation in 2050. We're going from 1.3 to 10, and there's no reason to think that column is going to get lower. Okay, that's the bottom. So now we have to think about how to get out of this situation. So I have been working for a while on publications and projects that explore and, in some cases, test some ways of meeting these threats. The current list, meaning the list that I'm trying to develop, contains 16 initiatives. I'm not going to be able to talk about 16 initiatives today. Instead, I'm going to pick out of this list a subset, I think 5, and talk about them. And in the Q&A period, if you want to talk about any of the others, I'll be happy to do so. So the sequence here begins with relatively easy interventions and ends with very large-scale, sweeping, and therefore difficult to implement interventions. The overarching theme is that there's no silver bullet. There's no one initiative that's going to solve the problem. Instead, the political and legal systems that are designed to manage pharmaceutical innovation and distribution create together a very complex machine. And there are opportunities for adjusting many parts of the machine. And one of the things that you have to be mindful of is to make each adjustment with awareness of the others. Because frequently, if you just adjust one lever, you're going to create side effects. And you have to anticipate them and offset them with adjustments in others. Okay, so let's take up a relatively simple one. We should have better systems for detecting and eliminating substandard and falsified medical products. Okay, the best system here is a track and trace system for following every pill from the manufacturer all the way to the moment it's consumed. Turns out that's super hard and expensive, and even the US doesn't have one fully in place yet. So until we get a full-blown global track and trace system, we have to do something more modest. So I've been working with some colleagues at Harvard, including Ruth Okedici, and the organizations listed on your screen to develop and pilot a technology that can substitute for track and trace systems temporarily. How does it work? Well, it consists of a near-infrared scanner, that's the device in the upper left, and a smartphone, a generic smartphone, which has loaded on it some custom software developed by a Seattle company called Global Good, which is funded by the Gates Foundation. And it also has on it, meaning the smartphone has on it, a database which consists of a library of profiles, spectral profiles of authenticated medicines. So the way you use this device, when I say you, an inspector in the post-marketing surveillance systems of public health departments in developing countries takes a scanner and an associated smartphone and goes to a pharmacy or a hospital, turns on the two devices, takes a pill out of a randomly selected packet, places it on the device, and then, in a menu on the smartphone, ascertain what the pill purports to be. Clicks on that, and then uses a camera to take a photograph of the packaging, which is the key element in gathering data, put the pill on that tiny little window on top of the machine, press scan, and if the spectral profile of the pill in question matches the authenticated profile, it shows up green, and if it doesn't, it shows up red. The records of these scans are temporarily retained in the smartphone, and then when the inspector is back in contact with the internet, are uploaded. And that enables the country in question and all other countries with whom the data is shared to locate hotspots, meaning areas in which counterfeit drugs are entering the system, and to cancel contracts with the suppliers of products. The advantages of the system are, first, it's very fast. It takes a few seconds. It's inexpensive. Now, to be sure, that near-infrared scanner costs $800, and the phone costs about $200. But each scanner can do this procedure at least 40,000 times. I don't know actually that number because none of them is worn out, but estimating 40,000 times. Training the inspectors requires only a few hours. This is a training session we conducted in Namibia. It enables quick, random tests of pharmacies and distributors. So this is a test we ran in rural Malawi. So you can see the pharmacists are a little uneasy looking over the counter here at the process. Each participating country benefits from the data gathered in other participating countries. And as I say, the data can be used to purge the system of bad drugs and to do contracts going forward. So the system, we piloted just before the pandemic in those two countries and was sufficiently promising that the World Health Organization bought 50 of these devices and distributed them to schools of pharmacy in Africa and are training pharmacists in how to use them. So the point here is not that this is the best technology possible. It's pretty good. Indeed, there's been a fair amount of empirical studies comparing the different technologies that indicate this particular one is as good or better than anything else on the market right now. But it will not be indefinitely. Better systems will come along. The point, rather, is that relatively modest technological innovations can address one dimension of this problem, and we should. This is in the category of win-win-win solutions. Patients benefit, doctors benefit, pharmaceutical firms benefit because their markets grow and their reputations are not tarnished by being associated with falsified drugs. The only people who lose under this system are counterfeiters and corrupt government officials who are working with the counterfeiters. Okay, so that's one. Now we're going to turn to a somewhat more complicated initiative. This is voluntary licensing. So I'm going to do this by example. As of 2005, the global death rate from AIDS looked catastrophic. And then starting 2005, 2006, it went down. Why? It's because of the emergence of antiretroviral drugs, of which the most important was tenofovir, developed by Gilead Sciences. And then Gilead, led by a wonderful senior vice president named Clifford Samuel, decided to issue on this patented drug licenses to generic manufacturers around the world, several of which are located here in Europe, licenses that had field of use limitations. In other words, they specified the countries in which the products could be distributed, not including the richer countries in the world. and in a variety of ways I'll discuss in a minute, set up the system so as to drive the price down. And it worked. The prices went from approximately 500 US dollars per dose down to about 140 very rapidly, and then kept declining. Okay, that's not the only source of the campaign against AIDS. The other was money, which came from various global funds and PEPFAR, a US initiative, sponsored, surprisingly, by President Bush. These two things together, voluntary licensing, radical reduction in the prices in poor countries, and a surge of money produced this, which is extremely rapid growth in the availability of ARVs, while they're still patented. So in this chart, the little red lines on the top, those are the distribution of the branded patented drugs. And the pink lines, those are all the generics. So by 2016, Gilead itself was distributing its products in one of these fashions to 10 million people. Other firms followed suit, so the total number by other producers of ARVs was, by 2016, was 19 million. It's now in the order of magnitude of 30 million people gain access. And this is what happened. The blue zone here is the number of deaths averted through access to antiretroviral therapies. It's about 16 million people, and this guy did it. Okay, so now let's generalize this model. This is voluntary licensing. And what I'm going to just show you is a very brief summary of a report from a project that Clifford Samuel and some other scholars and I did over the last 2 years on what, from Gilead's experience, could be distilled concerning the most efficacious way of doing this. So we're now veering, for those of you who are interested in it, away from intellectual property law into contract law. Now we're entering the zone of licensing. So, in a radically simplified form, a licensor, meaning a pharmaceutical firm, in the ordinary course distributes drugs in high-income countries by entering a deal with a contract manufacturer, obtaining approval by the local regulatory authority, selling the drugs to distributors who make them available to patients, many of whom are indemnified by insurers, more in Europe than the United States. The standard way of distributing drugs in low- and middle-income countries is basically the same. You get approval from the local regulatory authorities. The contract manufacturer sells the drugs both to private purchasers and government purchasers, who tend to be much bigger in developing countries. Funders from the outside, governmental or philanthropic, sometimes provide money to the government purchasers. For example, virtually the entire health budget in Malawi comes from outside the country. And then the drugs are distributed to distributors and delivered to patients. Are there insurers? Yeah, a few, but many fewer than is true in wealthy countries. This system, this is the standard marketing system, does not work very well. It tends to result in modest numbers of drugs being made available in poor countries at high prices. So voluntary licensing is a system in which you work around this. And the licensor enters into voluntary licenses with generic manufacturers, typically more than one, and they then sell their generic products to the government purchasers, and the private purchasers deliver them to patients. Okay, so far it's quite simple in principle, but it turns out that this is all you do, it won't work. You need to have some other features or aspects of this, and then it will work. Number one, multi-party deals. It's a mistake to think of a voluntary license as a deal just between a patentee and a generic manufacturer. You also have to engage the government purchasers early on, the local regulatory authorities to commit to expedited review, and funders. And if you get them all on board to collaborate, then it works. Next. Counterintuitively, you don't want a license to an unlimited number of licensees. You want to keep the number relatively modest. Why? Because thereby you get high quality products, you build long-term relationships between the licensor and the licensees, and each of the licensees has the incentive to respect fields of use. This is one of the ways of addressing the anxiety of many licensors that are going to lose control over proprietary technologies. Number 3, local production. As I say, this is one of the byproducts of the catastrophe of the COVID vaccine era. Many countries now insist that one of the licensees be a local generic manufacturer to which they are willing to make advanced marketing commitments with a price premium. Next, technology transfer. You can't just issue a license and expect people to build the factories and make the drugs. You have to provide information concerning how the technology works. And the best way to do that is rotating apprenticeships. When you bring workers into the plants in the US, Europe, or India, and you teach them how to practice, then it turns out many of the generic manufacturers, Clifford's discovery was this is true of the manufacturers in India and Pakistan, are actually really good at what they do, and they develop refinements. And so many of these contracts contain so-called grant-back provisions in which the manufacturers in the developing countries provide information that goes back to the licensors and then are shared with other licensees. Next, there should be a residual role of a branded version of the drug in the country. Why would you do that? Well, the reason, turns out, is that the manufacturer, in this case Gilead, can discipline price competition because the presence of the branded version, deliberately marketed at low prices, caps what the generic manufacturers can charge. Finally, almost finally, you need to exclude unauthorized generics. Do you need a patent for this? Actually, no, you don't. It turns out that trade secrecy, data exclusivity, and trademark protection are enough. This, in the various meetings that we had with manufacturers about this, preparing this report, was by far the most controversial of the topics, but there was finally grudging agreement on this proposition. And finally, transparency. There's no reason why these contracts should not be made publicly available, although many of them are not. Okay, that's number 2. I have 8 minutes to go. So I'm now going to talk briefly about a topic that has been received a good deal more attention in the literature. I'm going to suggest a few unconventional contributions, and that's how can and should we adjust the intellectual property systems in developing countries to facilitate wider availability of inexpensive drugs. So any initiative of this sort has to operate under the umbrella of treaty constraints, which set limits on what adjustments in the intellectual property system can be engineered. In India, you're especially attuned to this because TRIPS Article 27 was basically instituted so as to force India to adopt product patents for pharmaceutical products. Okay, so it's nevertheless possible for a developing country, without violating these constraints, to do the following things. The most obvious is if it's a really poor country, a so-called least developed country, or not a member of the World Trade Organization, you don't have to have patent protection at all for drugs yet. Weirdly, many of them do, but they should not. Number 2, a country can and should use a credible threat of compulsory licensing or parallel importation to catalyze voluntary licenses. That's what Brazil did early on and successfully beat back the HIV epidemic in Brazil, not by imposing a compulsory license, but by threatening to do so. The number of compulsory licenses that have been used to date is quite small. So you see a surge around 2004, 2005, 2006. Those were all HIV compulsory licenses, but very few of them made much of a difference in practice. What really made a difference in practice is, as I've already indicated, the voluntary licenses from Gilead and its other organizations. And since then, there have been very few. 2021, 22, 23, those are all COVID licenses, COVID therapy licenses, and very few of them have made a difference in practice. So, compulsory licenses can be a bargaining chip, but that by themselves are not going to do a lot of good. Much less obvious in most countries, although more familiar here in India, is that a country can tighten the inventive step and enablement requirements for pharmaceutical products and thereby limit the duration of products by lopping off the Me Too drugs. India pioneered this It was a quite controversial initiative, but it worked. This is a chart showing the evolution over time of the inventive step requirement in different jurisdictions. As you can see, it's been wildly variable. The reason I show it to you here is that critics of the recommendation I just made, namely to adjust the inventive step requirement, say, well, this would be to deviate from the stability of the international standard. There is no stable international standard. And so leaving open the possibility of significant adjustments is well within the zone of discretion of developing countries. Next, you can limit the duration of pharmaceutical patents. In the US and the EU, there are lots of ad hoc extensions of pharmaceutical patents to, say, offset the period of time spent in clinical testing. They're not mandatory, you just don't have to have them. Least obviously, the TRIPS agreement leaves open the possibility of limiting the availability of injunctive relief for the infringement of pharmaceutical patents. Indeed, ironically here, I say ironically because this was not the idea, the United States Supreme Court has led the way by radically curtailing the availability of injunctions for patent infringement of all sorts. And if that were done on a more routine basis in developing countries, it would create a system of low-level de facto judicial compulsory licenses, which would be much more effective than the vulnerable high-profile legislative or administrative interventions. Okay, so the general idea here is there are a bunch of levers in the intellectual property laws of developing countries that could be adjusted. The best known of those levers involving imposition of compulsory licenses is actually not so promising, but there are a bunch of others that are hidden. Okay, so mindful of limitations on time, I'm going to jump over what I was going to do is to provide a little bit of data concerning how the intellectual property systems in rich countries could be adjusted. And I'm going to move on to the most original and also least likely to be adopted of the recommendations in this package. So I'm going to present it not with a view, in order to convince you that it should happen in the immediate future. It won't. But it is, I hope, provide you a sense of how a complete rethinking of this field might solve the crisis. So here's the proposal. Almost all mechanisms designed to channel innovation in pharmaceutical products are carrots. They are incentives designed to pull potential innovators into directions that are going to be lucrative. What I'm going to describe now is a stick. It's a regulatory intervention. And here's how it would work. Suppose that every pharmaceutical firm were required each year to achieve a ratio. And that ratio consisted of fraction, the numerator of which is the total number of disability-adjusted life years. This is a measure of health benefit developed by the World Health Organization, saved as a result of the distribution and consumption of the firm's products during the year. In other words, how much good did the company's products do in terms of combating disease? Believe it or not, we have the data necessary to calculate this. Many of it assembled by countries like the UK and New Zealand, which track the health benefit of drugs. And then we have lots of data concerning how widely distributed they are throughout the world. So you might think, all right, that's got to be a hard number to calculate. Much less difficult than you would think. And the denominator is a measure of the firm's size. Presumptively, it's global gross revenues during the year. Okay, so that's the fraction. So just as car manufacturers are in the United States required to achieve each year a across the fleet minimum ratio of fuel economy, so here pharmaceutical firms would be required to achieve each year this ratio. Many firms are not currently in compliance with the ratio, so what could they do? Well, there are a lot of things they could do. Number one, they could reduce the prices they charge in developing countries for drugs already in their portfolio, thereby increasing the number of people able to afford them. and increasing their ratio by earning a lot more dollars. Number two, they could alter the formulations of the drugs so they could be distributed more easily, so less dependent upon cold chains or more suitable for pediatric administration. Number three, increase their investment in research projects that promise to generate drugs with large health benefits, like a better malaria vaccine, or a vaccine that will address any of the neglected infectious diseases rampant in the poor countries in the world. Number three, don't do it in-house, but instead adopt a business acquisition policy that would acquire startups that are developing products with big health benefits. Most pharmaceutical firms do this a lot now. It would alter their business acquisition strategies. Number four, collaborate with governments or NGOs in developing countries to improve the distribution systems. You don't just drop the drugs on the dock and hope something happens. You work with the public health authorities to ensure that there are mechanisms for getting the drugs to patients. Number five, buy dollies from other firms better positioned to improve public health. This happens all the time now with carbon caps in Europe. It also happens in cars. Porsche is always out of compliance with its requirements in the United States. So what does it do? It buys credits from Tesla. The reason why Elon Musk is so wealthy is because Porsche is paying him credits to meet the regulatory requirements. I'm exaggerating only slightly. The last possible intervention is reduce the prices of some or all of its products, thereby lowering the denominator of its ratio. This would work, although for obvious reasons, it's the least attractive of the things the firm could do. Now, the reasons for listing this here is because, in terms of economic theory, you want a regulatory environment that capitalizes on the informational advantage of the firms. Leave in their hands the choice of which of these approaches is going to yield the biggest benefit at the lowest cost. Instead of instructing them, build a malaria vaccine, you say, here's the target, you figure out how to hit it. That has worked for carbon, it's worked for fuel economy, it could work here. Okay, a few refinements. Like carbon, these dollies are bankable and tradable. I've already indicated tradable. They're bankable. You could save them across, just like you do tax credits. The regulatory authority can and should gradually increase the mandatory ratio. So each year, you click the dial up a little bit. And a company that failed to hit its target could pay a fine, thus creating a safety valve for the system, like baseball teams do. So the advantages of this approach, if adopted, is it would simultaneously address the access problem, the incentive problem, and this problem of substandard and falsified drugs, because the firms would have a strong need to address all of them, because all of them would improve their ratios. Next, you would, as I just suggested, capitalize on the information advantage of the pharmaceutical firms. Next, this system would enable extremely rapid responses to technological advances, pandemics, and changes in the landscape of diseases. So instead of requiring the World Health Organization to declare a global pandemic, and then for the US and the EU to develop a grant system and then pour money into the pockets of Pfizer and Moderna, the firms would respond immediately to the threats. And finally, it would foster public discourse concerning the global health crisis. Why would it do that? Because the price at which dollies are traded in this market would be a highly visible marker of the value we place collectively on a human life. So it would catalyze discussion of injustice and thereby contribute to collective movement in the direction of justice. Thank you.
Thank you, Professor Fisher, for what was a magisterial tour of the public health question and a sharp take on where intellectual property might fit. So for many of us who cut our teeth on intellectual property law, thinking about the drugs question in India in the late 90s as the TRIPS agreement was being signed. These questions have stayed with us across the research and the work that we've done in this field. So it's wonderful to have you here and to have you address this problem at a scale that I simply can't think of any other scholarship that is trying to map the questions as widely as you are and trying to tackle so many things at once. So thank you for that work and for this lecture. We have 30 minutes to take questions. We have a range of folks in the auditorium. I think we'll move on to questions straight away to give you the opportunity to step in. As Sandhya said as we started, just raise your hand and a mic will find you. Who would like to start? Yeah, behind you, Sandhya, left.
Hello.
Yep, coming through.
So the medicines developed in developed nations tend to be for Caucasian people. So is technology transfer really the solution, or should you have an alternative incentive-based regime against patent law in developing countries like India, considering that it's sort of a garage because of the diversity, the demography, and the sheer size? So maybe focusing on an alternative approach to patent law, some other kind of incentive, would that make more sense than merely just transferring technology from developed countries to developing countries?
Before I answer, can I, just for my own benefit, it would be helpful if when each of you ask a question, if you just identify yourself.
I'm sorry, I'm Geetanjali. I'm from National Law School. I'm an LLM student there.
Great. That's a very good and hard question. You're entirely right that the process of developing new molecules and then testing them often is poorly designed to attend to the distinctive variants of the diseases common in poorer countries and the conditions under which care would have to be delivered. Now, some of that bias can be mitigated by conducting clinical trials in the countries, in poorer countries, which many firms do for selfish reasons because it's less expensive. But it would be much better if there were mechanisms that induced firms to attend more closely to both the needs of and the technologies developed by the residents of those countries. So how? Well, the largest scale way of doing so would be to implement this social responsibility index that I indicated at the end, because that would put pressure on the firms to develop the most efficient molecules, and that's molecules that attend to local needs. Okay, but that's not going to happen for the foreseeable future, so let's talk about more practicable responses. Here's a specific example that may be illustrative. In French Guiana, in northeast Latin America, there are indigenous groups that have been living with malaria for centuries. And they have developed a tea made from plants that is effective at reducing malaria. The death rates, indeed the infection rates from malaria in this part of the world are very low, despite the fact they're endemic in the mosquitoes. So where's this tea, what's it made from? Well, it turns out a group of French researchers coming from France discovered that the Palicou group had found that Quassia amara, a plant was capable of producing this tea. So this is an illustration of a locally developed medicine that has proven to be at least as effective as artemisinin-based malarial treatments, which are the gold standard throughout the rest of the world. So what did the French firm do? Nothing, meaning they it's still in the process, this is ongoing. They're in the process of commercializing the molecule, but they didn't compensate either the country of French Guiana or the group in question until journalists brought this to light. And the public pressure on the French researcher was sufficient that they then provided compensation to both the country and the group. Okay, so lurking there is the possibility of a ecology in which the pharmaceutical firms that have disproportionate skill in refining molecules and testing them could and should draw more heavily on local knowledge and at the same time compensate the groups in question, and ideally also agree to engage in local production so as to provide jobs and local benefits. So that's one of the other 16 items listed up here, is a way of improving the loop that by which many drugs currently are produced and many more could be produced through dependence upon local knowledge and collaboration with the groups in question.
To our left.
Hi, I'm Kiran. I'm a student of public policy and also law. Regarding the 15th, in the solution, solution number 15, labeling requirements for traditional products derived from traditional knowledge of indigenous groups. I wanted to know how that solves the problems that we are currently facing.
So I missed the last sentence. Could you just tell me one more time what the key...
The labeling requirements for products derived from the traditional knowledge.
Yeah. This happens to be related to your question, which is, and is a topic that has come up previously in our conversations here. There has, for the last 30 years, been enormous resistance in the World Intellectual Property Organization on all initiatives designed to compel the developers of drugs to compensate or to share patent rights with indigenous groups from which the knowledge is taken. And every effort under the auspices of WIPO to overcome this hurdle have broken against the barriers erected by the United States, the European Union, and Japan. And it's not likely to change in the near future. However, it is possible, indeed has already begun, the treaty-making process has recently turned toward the imposition of a requirement upon patent applicants to disclose when they are making use of information developed by indigenous groups or accessible from other countries. Why does this matter? Why is this anything other than just merely a superficial change? It's that there is now in the world a widespread sense that it is parasitic and unfair for Eli Lilly to develop a childhood leukemia drug without compensating the indigenous groups from which the knowledge of the medicinal power of the rosy periwinkle came. And that pressure can be used strategically in this area to force the firms to compensate. There's a limit, unfortunately, however, to this tactic, and that limit is it only works in contexts when there's more than one treatment alternative available to the public. Because if there's only one, then no amount of public outrage will have much impact upon the firm. So, once again, this is not a silver bullet. It won't always work, but sometimes it will, and it did in the French Guiana quasi-Amara context.
Good evening, sir. This is Yash Vikram Singh from the LLM cohort of National Law School. So on one hand, we see that the slide showed us the neglected tropical diseases which are not taken care of, because mostly the big pharmas, they belong to the global north and they do not feel any incentive to work upon the diseases. Then on the other hand, sir, we have diseases like which go on for lifelong and for which the mitochondrial replacement therapies can work really well. But then in those scenarios, we see that the policymakers end up having the argument of not disturbing the Rubicon of germline per se. So how do you see this dichotomy, that is it the policymakers who end up not wishing to have certain specific solutions for certain diseases, or is it the patent holders, or is it the pharmaceutical firms which eventually end up not wanting to have solutions for these diseases, where they can have much more money via the lifelong medicines as compared to having solutions to these problems?
There is, unfortunately, in intellectual property law in general and in much of the public health literature, an assumption that private firms will always operate to maximize their profits, and that the only mechanism by which their efforts can be turned to better promote the public good is through the intervention of governments, typically national governments, although occasionally global governments. So this image contemplates accepting a renunciation of moral responsibility by the firms and concentrating moral responsibility in government officials. This heuristic, this conception has existed for a very long time, and it's a bad idea. It's surrendering it's sacrificing many opportunities, and it's surrendering the high ground of morality to skeptics. We should be trying gradually to cultivate institutional mechanisms that enlist the leaders of the firms in an overall practice of socially responsible behavior. It's hard, it's slow work, but one of the reasons why I described in some detail the successful initiative by Gilead to engage in voluntary licensing in the HIV space is that is an example of an initiative that doesn't fit the model. Gilead did not have to engage in those licenses. Why did it do so? Well, primarily because the CEO at the time, a man named Martin, was troubled by the horror that would ensue if sub-Saharan Africa, where there were 25 million people infected with AIDS, were just left high and dry. And he empowered this senior vice president I mentioned, Clifford Samuel, to set out and engage in practices that were not profit maximizing. So internal to the company, Samuel was mocked and denounced by the other executives because he was engaged in what they considered a hobby. But he persisted and he experimented. I hope I didn't leave the impression that he just had an idea and implemented it in one fell swoop. There was a lot of experimentation, things didn't work, he tried this, tried that. And in the end, he saved 16 million lives. That's a model that we have to celebrate and generalize. It's one of the reasons I told this story here now. A lot of this is going to be one step forward, two steps forward, one step back. So, to be blunt, Gilead is no longer led by a CEO who has a similar impulse. Gilead is not behaving on the same principles now. So you shouldn't come away with this with a sense that, well, there's a heroic firm. GSK in the UK was for a while led by a CEO who had similar impulses and no longer. So it's a bit by bit progress, but I'm hopeful that we can, over time, shift moral responsibility away from exclusively relying on government officials and instead rely upon the leaders of a combination of private firms and non-governmental organizations. We should all be shouldering collectively the task of addressing the global health crisis and not assume that national legislators are going to carry the ball altogether.
Good evening, sir. So this is Tasneem from Ramaya University, Bangalore, and I'm an assistant professor here. And I'm currently pursuing PhD in identifying the role of compulsory licensing in access to essential medicine in a developing country, especially with reference to India. So my question is more than seeking an opinion from you. What do you think about a scenario? Till what extent the licensing or compulsory licensing is actually having an effect on access to medicine? Because if we take the situation of COVID in India, it actually surpassed all the patent rights and they managed to do it even without the patent thing. So from where exactly are we coming to the question of licensing or compulsory licensing when we actually made it happen even without the IPRs?
So one of the non-obvious and I know controversial themes I suggested during the lecture is that there has been excessive reliance in the activist community broadly on compulsory licensing as a solution. So the most recent example of this unfortunate focus was the extraordinary amount of diplomacy and agitation and journalism focused on the COVID vaccine waiver under the World Trade Organization and the subsequent debate over whether to extend it to diagnostics and therapeutics. The principal actors in that area, including the CEO of Moderna that I described, were very happy with this because it deflected attention from what mattered. mRNA vaccines are very hard to produce. It took a year for the South African firms to reverse engineer it, and they're still not fully up to speed. Control over the technology is far more effective, and compulsory licenses cannot force disclosure of proprietary information. This limitation of compulsory licenses is just going to keep getting worse because we're increasingly relying on biologics, monoclonal antibodies, mRNA vaccines. None of these are small molecules that you can just say, Cipla, go forth and make a generic version. And so one of the things I'm trying to convey here is that if our goal is to maximize access at affordable prices to the new medicines, those under patent, we should do so in other ways than compulsory licensing.
Hello. Hi, good evening, sir. This is Jogeshwar. I'm a patent attorney. I practice as Shardul Amarchand Mangaldas. What I'm trying to say is probably not a question, but a conundrum. How much do you think does geopolitics have a role to play in all of this? The reason I'm saying is, let's say, for example, India. Now, India is one of the systems which has really a holistic way of covering all of the issues that you raised in respect of intellectual property in your main slide. We have a very high standard of assessing inventive step. We have section 3D for people who may be interested, which effectively prevents evergreening of drugs. We have a statutory compulsory licensing provision. We have a government-imposed compulsory licensing provision, and we have other provisions which effectively provide, including provisions like pre-grant and post-grant oppositions for patents. However, what I have felt is that geopolitics has a very strong role to play. Now, when India passed its first and sole compulsory license on imatinib mesylate in 2013 in the Bayer versus Natco case, there was a huge hue and cry, particularly from the United States trade representative, and we have had to make arguments over at USTR so as to avoid trade sanctions. Now, how much do you think does geopolitics have a role to play in all of this? Because it is all interconnected.
Another good, hard question. The bottom line is a lot. There's a great deal of impact of struggles among nations that affects not just which laws are adopted in each jurisdiction, but the degree of discretion that in practice is exercised by the countries. Much of this is blunt, that as you point out, the trade representatives of the United States and the EU retaliate against countries that use the compulsory licensing mechanism. Okay, we're just going to bracket for the moment whether I think it's optimal to use compulsory licensing. Let's just assume that treat this as a effort to address a health crisis. It's an outrage that the trade representatives retaliate. In lots of other fields of law, landlord-tenant law, civil rights law, we have whistleblower laws, we have regimes that shield people who exercise legal rights, for example, to complain about the quality of their apartments. It's outrageous that the countries with clout punish other countries when they seek to exercise their legal privileges. Now, I testified to that effect before the United Nations High-Level Panel on Access to Medicine some years ago, and the final report of that group agreed that it's outrageous and said, you know, countries should not do this. How much impact did that have? None, zero. So what that means is that countries with sufficient economic power to resist pressure do so, and that includes India. One of the reasons why India was able to sustain its reinterpretation of the inventive step requirement in the Novartis case is because the country at stake, which is Switzerland, is small, and they just don't have the clout to lean on India. Brazil is also able to push back against the pressure and did so in the HIV context. Thailand is not quite in such a good position. They've used compulsory licenses and faced retaliation both from firms like Abbott and from the USTR. So the basic message here is the smaller the country, the weaker it is in trade negotiations, the more it gets pushed around. So what I suggested to lawmakers in Namibia and Malawi, you know, there's this opportunity you can have to adopt this. And they look at me like I'm crazy. What did you think will happen in our trade negotiations going forward if we use this lever? So the short answer is it makes a big difference. Okay, now the last thing I'll say about this, however, is that administrations change. We in the United States are on the threshold of a existential election, and just one of the outcomes of that is going to be the willingness of the US government to, on myriad fronts, take seriously the welfare of people in other countries. The US is not alone on this. The rise of authoritarianism everywhere has as one of its dimensions nationalism, and within each country, insensitivity to the welfare of disadvantaged groups. And India is not immune to this disease. So, short answer is, it matters a lot, sadly.
So we have 5 minutes leading
Yeah.
up, maybe 2 more questions. Yes, please.
Yeah. I'm Rakesh Gupta. I'm a retired government servant and have been a regulator and a judge also. So I want to ask you a question. You see, if you see historically, the greatest inventions in the world, even the 2 vaccinations like Jenner and others, there were no talk of any patents at that point of time, just for humanity. And even the most of the important discoveries made by scientists, they were not patented. They were just given away free and improved upon. Now we have a model in the software industry of open source software and a monopolistic proprietary software like Windows or Microsoft. And the open source software has a system that it's given away free and people can improve upon it and also distribute it freely subsequently. There's no patenting rights or any legal rights over the new product developed on the old product. Why can't such a model be used for developing of drugs? For example, even for malaria, the traditional medicine was from bark, from quinine, and that was not patented. And the new products, which are other quinine, other products, are basically being patented around based on some traditional knowledge of earlier medicines. So, what is a legal position on such a situation? How can you tackle it legally that you can't patent something based on traditional knowledge or maybe earlier knowledge?
As you point out, there is a very widespread moral intuition in the world that securing intellectual property protection, including patents on innovations in therapeutic or surgical techniques, is fundamentally immoral, derived in part from the Hippocratic Oath and the view that the responsibility of a medical professional is beneficence. And that sentiment resonates with, as you also pointed out, the commitment of a subset of developers of software to make their fruits immediately available to the world. And that helps to explain the explosion of the internet because of the surrender of all intellectual property rights in it, and the proliferation of free and open source software, which is running much of the backbone of the internet and so forth. So we have these two streams, medical ethics and free and open source software. So why can't we build on that model in the pharmaceutical space? Well, sometimes we can and do, but there are two impediments that get in the way. One of them is that the technology necessary to identify and refine molecules is very complicated and therefore very expensive. And so, as a practical matter, tends to require large investments, and those investments tend to be concentrated in private firms that are working for the benefit of shareholders, and so it's very difficult to sustain the commitment to the public good in that economic setting. The second of the reasons is clinical testing. If I had my druthers, I would shift responsibility for clinical testing away from the firms that develop drugs onto the shoulders of government agencies to engage in nonpartisan clinical testing. One of the advantages of that shift is it would make it much less expensive to develop the molecules in the first instance, which in turn would increase opportunities for the kind of model you describe. But that's not the world we live in. There is, however, some hope on this front that we haven't talked about at all yet, which is artificial intelligence facilitated drug discovery models. They are rapidly reducing the costs of testing and predicting the efficacy of drugs and finding the optimal dosages and so forth. So it's conceivable that if AI drug discovery models accelerate fast enough, then the costs may come down to the level at which a form of innovation you describe could take hold. Not yet, but it might.
Apurva, for the last question.
So I'm Apurv. I'm a PhD scholar at National Law School. So I really liked your numerator-denominator model that you had at the end, but there is a fundamental question that I have about it. That doesn't that model also encourages economies of scale and inherently discourages being an innovator and encourages being a generic? Because if I'm an innovator, I will have investments to make ultimately. But if I'm a generic, I can play on the economies of scale. I can actually give it to more number of people, and I can earn and I will have the same amount of revenue as someone who's innovating. So if I'm, as an innovator, I have the same amount of revenue as someone who's a generic and who's not innovating at all. What exactly is the incentive to innovate? That's my question.
Yeah, it's a very nice question. Most major pharmaceutical firms today do not rely primarily for drug discovery on in-house research. They instead buy small startups where the new ideas are harnessed. Now, the majority of those small startups grow out of university-based research, and the majority of them fail because the ideas don't pan out. But when they succeed, then the major pharmaceutical firms acquire their rights. Now, in theory, they could acquire the patents or other intellectual property rights on that newly discovered drugs. They typically don't. They just buy the companies. And then they build on their models at scale, in just the fashion you described. Is that bad? Well, it's efficient, meaning it does get the innovations more widely distributed than would a more decentralized model. Is it inhospitable to innovative, independent researchers? Not really. It just means that if you have a great idea for a new drug, vaccine, you anticipate building it out until it's proven sufficiently credible that you sell it to a big firm and you move on. The, an anecdote here. Boston, as you probably know, is a hub for this kind of activity. MIT, the Broad Institute, the Whitehead Institute, and Harvard, they all are founts of innovation in the biological sciences, gene therapies, sequencing the human genome, and then building out into lots of therapeutic spaces. So what happens as a practical matter? Well, a postdoc or two in a lab has a great idea, and they begin reducing it to an increasingly practical form, and they start talking to venture capitalists. How do they talk to venture capitalists? There's a restaurant in Cambridge where they all gather and they schmooze and they talk about ideas, and millions of dollars are sort of circulating here. And if the postdocs are sufficiently persuasive, then the money comes in and they test out the molecules and the business takes off, and then they sell it to somebody else. Is that a bad world? No, not really. It's kind of high stakes. It's exciting, it's fun, a lot of good ideas come out of it. I'm not so sure that we should regret that structure in which innovation is decentralized, risky, closely associated with universities, and testing and distribution is large scale and centralized.
I'd like to thank Professor Fisher for making today's lecture not only a medical or legal issue, but a human one. The idea of well-being is something that both medicine and law try to achieve at a personal and social level. And I think it was important and interesting for me to see how legislation, guidelines, and if I may be so bold, activism can play in ensuring this, not only for the global players, but for the lack of a better word, the subaltern. So I'd also like to thank Professor Sudhir Krishnaswamy for the collaborative spirit with which NLSIU has always come to BIC. And I think it's produced some fabulous sessions for the general public. And we're so grateful to have organizations like this come to BIC and work on events together. Most importantly, I'd like to thank Professor William Fisher for his erudite and empathetic analysis and for his carefully constructed and considered responses to all the questions. And lastly, thanks to all of you, students from NLSIU and other universities and the general public for being part of this discussion. Thank you and have a good night.